Talk about expansion buses and networking in a server environment. Now in the CPU video we talked about the fact that most modern CPUs have several lanes of PCI Express. Now realize that's not the only expansion bus that's available inside of servers. And depending on the age of the servers, PCI Express may not even exist in a server. Much like in the desktop world, one of the oldest expansion slots that exist in the server world is the PCI slot. A very old 32 or 64-bit connection capable of up to 133 megabits per second, which is not particularly fast by today's standards. After PCI came PCI X, or PCI Extended. PCI Extended was a 64-bit successor to the standard PCI slot. It was a significantly longer slot, but offered up to 4 gigabytes per second of bandwidth and found its way into a lot of servers when it was first released. Of course, by far the most common slot today is the PCI Express slot. And we should be familiar with PCI Express slots from the desktop world because they're extremely prevalent there. We use them also in the server world. And much like in the desktop world, the length of the slot will determine the available bandwidth. So a PCI Express by 1 slot will be very short, a by 4 will be longer, a by 8 will be a little bit longer, and a by 16 slot will be the longest port. PCI Express version 3 or 3rd generation is going to be the most common. However, version 4 has recently made its way into the desktop world and is starting to make its appearance in the server world as well. One of the largest advantages of PCI Express, other than the amount of bandwidth it can move between CPU and card, is that the PCI Express slot is connected to the north bridge of the CPU, which gives it direct access to memory, what we call DMA, direct memory access. That direct access to memory drastically improves the performance of any card that is installed in a PCI Express slot. Because of that, PCI Express is taking the place of almost every other expansion slot in a server. However, in older servers, PCI and PCI Extended, PCI X, will still exist. When it comes to networking, much of the external is going to be very similar to what we would see on a desktop computer. We're still going to use an Ethernet port that would handle an RJ45 connector for Ethernet networks. However, in servers, one of the biggest differences is the number of Ethernet ports that we'll typically find. Many servers come standard with 2 Ethernet ports, plus a 3rd specifically for a management interface. It's not usable by the operating system as a port for, say, the internet or other network services, but it is useful for connecting that server up to a management console so that you can see state of health information, such as server temperature or whether a drive has failed or not. But the primary 2 Ethernet connectors, can be used just like any other Ethernet port on a desktop system. It's not uncommon, however, for servers to have 4, 6, 8, or even more Ethernet connections, depending on the services that we're trying to offer or the number of virtual machines that are running on that server. Much like in our desktop world today, where gigabit is still the primary speed, most servers are still going to have 1 gigabit per second Ethernet ports. However, 10 gigabit per second Ethernet ports are available, and as new technologies come out, they will certainly be available on servers. Additional network interface cards can be added through expansion buses like PCI Express, just like they can be on the desktop side of things. Another subtle difference between servers and desktops is that fiber connections become much more commonplace on servers than they are on desktops. Very rarely will those fiber connections be built into the motherboard of that particular server, but they're usually added through expansion cards like PCI Express. Those fiber cards offer significantly higher bandwidth, 10 gigabit per second, 40 gigabit per second, or even 100 gigabit per second, as opposed to the Ethernet networks, without adding as much cost as an Ethernet card at those bandwidths would be. However, those technologies are more often combined with a storage area network or used specifically for moving data in and out of storage, as opposed to being used for general networking as we think of in a desktop environment. A few things to remember when it comes to networking on servers. If you're going to get an expansion card to increase the number of network ports or network interfaces on your server, realize that the bandwidth of whatever expansion slots you plug it into must match or exceed the bandwidth of the ports that you intend to offer. For example, if you buy a card that has 4 10 gigabit per second ports on it, you must install that in at least a PCI Express by 8. If you install it in a slot that physically fits a by 8 but is electrically only a by 4, you'll only get the by 4 bandwidth and you won't have enough bandwidth for the interfaces on that card. Similarly, the networking capabilities of the infrastructure environment that you install your server in should meet or exceed the performance of that particular server. It doesn't make any sense to pay a bunch of money to have 10 gigabit per second Ethernet ports in your server if the rest of your network infrastructure is only gigabit. Another difference, if we dive into the details of networking between desktops and servers, is where the processing takes place on a network interface card. In the desktop world, network interface cards actually rely heavily on the CPU to do a chunk of the processing of that network interface card. So for example, when a frame comes into that network interface card and it needs to compare the MAC address of the frame to the MAC address of the computer, it's a simple task. It'll take place on the NIC. But if there's something more complicated, such as scanning the IP address or handling a TCP stream and reconnecting it, that task is typically performed by the CPU of a desktop rather than the chip or the NIC of that particular computer. Now, as you can imagine, on the server side of things, if we have 4, 6, 8, 10 network interface cards that are all trying to use the CPU to do basic networking tasks, those CPUs are going to be burdened by networking tasks that they're not really designed to do, or that it's really a waste of their computational power to perform. So network interface cards on the server side are typically more robust. They have significantly more resources, larger CPUs in the card to handle more of the networking tasks and offload that from the CPU so that the network traffic doesn't inhibit processing within the CPU. If you look at a network interface card for a desktop, for example, they're usually rather small. They don't have heat sinks on them. But a network interface card for a server is going to be significantly larger and usually will have a heat sink built in because the CPU or the processor for that network interface card is significantly more powerful and generates more heat than the desktop counterpart. We'll talk more about the logical side of networking in a future unit, but I wanted to give you an idea of some of the hardware aspects of networking in this video.